Thanks for joining this webinar that's presented by Humanitech and Neurware. Hopefully you're here to answer the question, does your team need an internal developer platform? My name is Chris Stevenson and I head up engineering and product here at Humanitech. In the next 20 minutes, we'll cover a few things. We'll discuss what actually is a developer platform. We'll also examine why you might need one. And of course, because this is Humanitech, we'll also explain how Humanitech can help you provide a developer platform to your development team. I'm going to make an assumption straight away that you are interested or you're familiar with the concepts presented in the Accelerate book and the various State of the DevOps reports that have been released over the past few years. And of course, how these can be applied to Kubernetes. So this presentation and the discussion about developer platforms in general will cover how DevOps will intersect with Kubernetes and how you can make that experience better for your developers. So let's jump straight in and revisit what we mean when we talk about DevOps. So in the old world, we used to have developers who lived in their own little world, and we had operations people who lived in their little world. So when a developer wanted to have something released or deployed, what they would do is they would pass the artifact over to the ops team, and then the ops team, who had access to all the infrastructure, would go and deploy that artifact into the infrastructure. Then along came the idea of DevOps, and the promise was that if, rather than living in their own separate worlds, developers and operations people worked hand in hand, they could be involved in the entire process all the way along. And we have concepts like developers carrying the pages for production and ops teams getting involved with the early design of applications. Now, in practice, what really happens is that developers are still mainly doing developer stuff and ops people are obviously focused very much on ops stuff. But in a real-world DevOps setup, we do have a lot of overlap between the two, and we do have ops people involved in application design, and we do have developers who are responding to pager events for production systems. So what happens when we add Kubernetes into this mix? So the problem is that Kubernetes tends to land very heavily on the operations side. Now, why is this? Well, there's a few very good reasons. The first one is that Kubernetes is just really complicated. There's a lot going on. You need to install it in relatively complex infrastructure with multiple nodes. You need to manage it. You need to manage permissions. You need to worry about provisioning things like persistent volumes. You need to understand how to configure ingress and DNS and so on and get your networking right. So there's a lot that needs to be done, and that generally falls on the shoulders of the infrastructure team and so lives in the operations world. The other problem is that it needs to be maintained. So Kubernetes is actually a relatively fast-moving bit of technology for infrastructure. It has very regular releases, and things need to be updated and progress over time. In addition, you also need to make sure that things are working. You need to make sure that when nodes go bad, they're taken out of node pools and recycled in. And you also need to make sure that people have a good idea about what's actually running where, how to monitor it and make sure that things aren't snarling up. And finally, debugging is daunting to a non-expert. So as a developer who is maybe familiar with container technologies, coming to Kubernetes is actually a pretty scary thing. You have to worry about these things called pods. You have replicas, you have local load balancers, you have services. How do these things fit together? What do I need to look at to work out why my application is producing this error? Or why is my application not even starting? What is a crash loop backoff? So all of these things are things which are confusing and a little scary. And so more reasons why the operations team tend to be the people in charge of running and maintaining Kubernetes setups. So what if you want to kind of reset the balance? What if we want to try and balance things out so that developers are a lot more involved in Kubernetes deployments alongside their operation teammates? Well, as we mentioned before, there's a lot of complexity, there's a lot of new terms, there's a lot of things that developers need to learn which are outside of their scope that they would normally be dealing with when just writing code. So your average Python coder is probably not familiar with pods, with persistent volume claims, things like stateful sets. And so they would have to learn these things and have to understand how they work over time. Now, of course, the operations team have a whole load of things which they're managing anyway, things like clusters, node pools. They're worrying about things like high availability. Maybe they're concerned about access into their clusters. But as you can see, even if we try and split things up, there's still a lot of stuff. And the underlying point is that you still need to train your developers in order to get them to understand what's going on in Kubernetes. So if we think for a moment about the kind of setups where people are using Kubernetes, let's split things up into a world of small generalist teams. We're talking teams of 10 to 20 engineers, and we have larger teams. We're talking here hundreds of engineers. Now, with a small team, maybe you can get away with training up everyone in your team on Kubernetes. You have, say, 20 engineers. Everyone is going to get a touch of Kubernetes at some point. So every engineer probably at some point needs to deploy a service. Every engineer probably has to dive into logs to figure out what's going on inside an application. And this is especially true with a small team because people need to cover for each other. If someone's on holiday or someone is busy with something else, then everyone kind of has to cycle in and they build up an understanding and they're very motivated to understand it. And especially in small teams, people tend to be more generalist. They have coverage over lots of ideas, lots of technologies, and they're comfortable working with a certain amount of ambiguity and a certain amount of chaos around them. Now, if we switch over to large teams tend to have a load of specialists in them. So everyone isn't a generalist here. Maybe you have a load of data engineers, maybe you have some specialist people dealing with special types of databases, maybe you have your enterprise Java people, and these are people who don't necessarily know anything about Kubernetes and actually may not want to spend time learning and getting familiar with the details of Kubernetes. And also, as the teams get larger and you have specialists, you'll have people who specialize in Kubernetes itself. And in general, these are the developers who will get involved with doing things like deployments, doing things like debugging, helping their teammates do various things. The other thing to think about is as you get to large teams, the work tends to get spread out anyway. So imagine you have 100 engineers, maybe you have 30 microservices that the 100 engineers are managing, maybe you have 100 microservices engineers managing, but only a few people will be doing the general jobs of doing the deployments and actually running these things day in, day out. So maybe as a small team, Kubernetes knowledge can be easily spread around, but on a large team, this becomes increasingly problematic. Now, one of the reasons this becomes problematic is something called cognitive load. So if I imagine myself as an enterprise Java developer, I am already thinking very much about my business logic. I'm thinking very much about how the JVM can help me build my code, and I can make things that run effectively and are maintainable and are testable and so on. If I have to throw into the mix also working out the commands needed to deploy my Java application, I have to work out how to tune resource parameters so they work well with the JVM and so on. That is a load of additional work. And that is what we call additional cognitive load. So John Sweller is the person who came up with the concept of cognitive load theory, says that cognitive load is the amount of mental effort being used in the working memory. Another way of putting that would be, it's how much stuff you need to think about to do a task. And in general, if I'm a specialist in something, stuff that is outside of what I normally have to deal with is additional mental effort. And so that's going to slow me down, it's going to make me frustrated, and in general, that's a bad thing. So especially as your teams get bigger, the cost of cognitive load, increasing cognitive load, becomes greater and greater and greater. So what advice is there out there for deploying Kubernetes, but then maybe trying to avoid these problems of cognitive load, training up all of your developers, and so on? Well, there's a chap who's pretty famous in the Kubernetes world, a chap called Kelsey Hightower. And what he says in this tweet is he talks about Kubernetes as an implementation detail. So he talks about having Kubernetes running the project, but developers are not interacting with it. He describes it as a change management system running on top of Kubernetes. And you can imagine that is basically is developers saying, hey, I want to run this thing, Kubernetes, just go off and run it for me, rather than configuring Kubernetes in the detail and getting things done. There is actually a word for something like this, or a phrase for this, and that is internal developer platforms. And what we find is that big companies tend to have built these internal developer platforms already. So the likes of Spotify, Airbnb, and Zalando have noticed that it's more efficient for their developers to be focusing on writing code and not very efficient for them to be worrying about the intricacies of how to use Kubernetes or how to get their code running on Kubernetes. So let's take an example. So one company that famously improved the developer experience for working with Kubernetes is Airbnb. So this is all taken from a talk which was given at KubeCon in London last year. And Airbnb at the time had over 1,000 engineers and was running 250 critical services in Kubernetes. And they were doing roughly 500 deployments a day, all of this running in Kubernetes. Now, we can look at these numbers and we can already deduce some things about that. So if you look at 1,000 engineers, 250 critical services, and 500 deployments a day, we can already see that not every engineer is going to be deploying every single day. In fact, in practice, you're probably going to have a handful of engineers who are actually doing the deployments for all of these services. So at least probably 1 in 2, maybe 1 in 4 engineers are actually dealing with Kubernetes on a day-to-day basis anyway. So we can see that the other people are going to have this problem where they don't interact very frequently, and so therefore they are going to, their skills will get rusty, and when they do want to interact, they're going to have to ask their colleagues or read up on documentation and so on. And all of this increases their cognitive load and makes it trickier for them to do their job. So what Airbnb did is they built basically an internal developer platform. They developed a platform that their developers can use so that they can work effectively with Kubernetes. And if we just grab a slide from that presentation, what we see here is that they split out the problem of deploying to Kubernetes. So this is just one part of the presentation. The platform is actually much bigger. I would highly advise you go and have a look. I'll send an email at the end with details about what you're about this talk and so on, so you can follow up for yourselves. But if we look here, the basic principle is that the developers are working on the left with things they understand. They're working with projects, they're working with apps, containers, files, volumes, and the Docker file to kind of pull everything together. Then their platform has a tool in it called KubeGen, and that takes all of these things and generates the whole mess of manifests that are required in order to actually deploy something to Kubernetes. And then the last of the process is an automated step where they basically do a kubectl apply to get things into the cluster. But the important thing is that the interface for the developer is a load of things that's familiar to them. So concepts and configuration that they understand and exist in the domain of what they're working in. So this means that developers don't have to learn Kubernetes. They don't have to understand the details of what's going on. Someone else can manage that for them. In this case, the platform team that built this internal developer platform. And the developers can then go about their day making sure they're working effectively and successfully throughout their project. Now, this was very successful at Airbnb. They, as you saw from the previous stats, they have over 1,000 developers using Kubernetes through this platform, and they're able to ensure high performance of their engineering teams and also a very maintainable Kubernetes setup. So we've kind of talked around it and we've given an example from Airbnb, but what actually is a developer platform? Well, to start off with, let's cover the aims. So the important thing about internal developer platform is it's for developers. It aims to improve the developer experience. And the main way it does this is by reducing cognitive load. So we want to reduce cognitive load, and if we reduce cognitive load, then we improve the developer experience. Happier developers, less developers that have to deal with less complexity are more effective, they are happier, and they then tend to produce better software. Now, how this all works, we, as a developer platform, we want to do things like make configurations easy to update. So one of the big problems that you have, especially in Kubernetes, is that most of what's going into your application manifest is configuration. Managing that configuration, dealing with multiple environments, understanding how this works is the source of most of the complexity. So a good internal developer platform needs to make the configuration easy to update and understand. As you saw in the Airbnb case, that was done by those input files, making sure they're all clear and easy to understand. The second thing is making deployment simple. Deployments is the kind of traditional barrier between developers and operations people. If deployments are hard or if deployments require support, then you're not really living a DevOps lifecycle. So you want to be able to have developers deploy easily when and whenever they want without any kind of impediment. Then we also want to make sure that provisioning of technology is self-service. So developers shouldn't have to go and ask someone or file a ticket to get a database set up. They shouldn't have to ask someone if they can have a DNS entry pointing at their new service they've deployed. So an internal development platform should be the platform that empowers developers to actually get the tasks they need done without relying on other people. And finally, we want to make debugging easy. So in the Airbnb case, if you follow the talk, they have a whole section about how you'd actually debug using that platform. But fundamentally, debugging something like Kubernetes is very tricky, especially if you're not familiar with the concepts. So the platform should surface what is important to a developer and not surface things that are not important to a developer. Most debugging is probably to do with what's going on in the application, so things like access to logs, maybe having some ability to inspect what's running in a container is super useful. Hopefully the developer platform has avoided common problems with things like ingress or things like network configuration already to reduce the surface area that the developer needs to worry about when they are trying to debug. Now, finally, the most important thing about an internal development platform is that it is used by developers and it is administered by DevOps. So when we talk about things like provisioning technology or making sure that deployments happen well, all of this thing needs to be kind of managed and run by DevOps. So we need to have DevOps, or in some cases it's called a platform team, who are managing the platform and making decisions that then allow developers to get their work done quickly. So I'll give you an example. If you need a Postgres database for your service as a developer, I don't really care how that Postgres service is provisioned. I just want to make sure that I can access a Postgres service, Postgres database, which can be used by my service when it's running. So someone on the platform team has said, we provision Postgres databases, for example, using RDS in AWS. And so they have defined how this Postgres database is provisioned, and the developer just needs to say, yep, I need a Postgres database, give them Postgres database, and the platform team or the DevOps team have already configured the platform to produce and provide the database that's needed by the developers. So that's great. We understand what an internal developer platform is. Why might your team need an internal developer platform? So we've already touched on one of the parts, which is to do with size of team. So if Kubernetes knowledge is not very evenly spread in your team, you say you have a large team and there's a handful of people that are doing the interaction, so doing the deployments, doing the general management, adding resources within the cluster, then having an internal developer platform can help democratize that Kubernetes knowledge by reducing the skill gap needed for the rest of your team to be able to interact. Other things that are kind of warning signs, which might be why an internal developer platform might be the way forward, are developers being blocked by necessary ops processes. So we've already talked about things like provisioning resources like databases. This is a great example of, if you have a bottleneck here, this is a great example of when you might be wanting to think about having an internal developer platform. And then finally, this is kind of related also to the the concept of having a continuous delivery system. If your deployments are slow and feel risky, then it probably means that your general processes are not well defined. Usually this means that lots of people are involved, or that the processes are manual and kind of one-off, and there's a lot of siloed knowledge. So one reason why that could be is maybe deploying into Kubernetes is something that only a small handful of people know. Maybe having an internal development platform that allows people to deploy at the click of a button or the run of a command would be a much better way of going forward. So what can you do with your developer platform? So here are some common tasks that I think are useful and the developer platform can open up. Maybe something that's not possible with a kind of standard setup. So the big one is spinning up new environments. So often you will have your staging environment, you'll have your production environment, and you might have a shared dev environment. But how many times have you wanted to have an additional dev environment, maybe to test a specific feature? We talked to a company that blocked their staging environment for 2 weeks because they were testing a Stripe integration. And the QA team needed 2 weeks to actually accomplish the full testing of this. So what happened there is that the rest of the developers were developing features, they were sitting in the dev environment, and there was a backlog. They were unable to deploy features to production because they couldn't use staging. It was too much work to create an additional staging environment. And so then they had to deal with a big load of changes after they finished the Stripe testing, which of course produces all sorts of problems with regression testing and so on and so forth. Another thing is managing configuration across environments. So if I have multiple dev environments or dev environment staging, how do I manage the fact that I've added a service to a dev environment and now want that to be deployed through to the other environments? How can I understand the differences between environments and make sure that my configuration moves successfully through, or I can kind of merge them in maybe from a feature branch into the main shared dev environment? We've already touched on the provisioning of resources, things like spinning up databases, maybe provisioning DNS names. These are tasks which is probably better to get a computer to do rather than a human to do, because machines are much better at repeatedly provisioning things and getting the same thing out each time. And then finally, a good internal developer platform can also allow you to inspect. We've touched on debugging, but one of the big things that an internal developer platform can really help with is understanding the changes between deployments. So what happened over time? I deployed yesterday, I deployed this morning, I deployed this afternoon. What are the differences? What is the material changes between those? How do they compare to the comparable deployments I made in staging? How do those compare to the original dev deployments that were made by my colleagues? Getting that kind of information and being able to audit who did what and what the actual changes were can become very useful when you're trying to do root cause analysis, or maybe you are trying to work out why something went wrong. So this brings us to Humanitec. So Humanitec is actually your out-of-the-box developer platform. And what do we mean by that? It means that you can start using Humanitec straight away and plug in your various resources and plug in your clusters and so on, and get a lot of the benefits that you get from building your own internal developer platform, but without the step of actually having to build it yourself. So we like to say that Humanitec is simple, it's extensible, and it's auditable. So just to kind of start on the simple bit, we're very focused on making sure that these kind of DevOps type tasks, things like deployments, things like provisioning resources, are really one click or one command for a developer. So as well as being able to plug into, say, your AWS account, your GCP project, or Azure, you can make sure that things like databases are just able to be spun up in those environments as you need. We talk one click, but we also sort of have a full UI. We have a CLI as well, and an API that you can use to automate any of these things as we go along. Now, because this is your internal developer platform, and this is an out-of-the-box developer platform, it's important that everything that exists in the platform is easy to understand and, most importantly, ties in with your infrastructure or your particular design decisions. So Humanitec provides you a set of sensible defaults, but it also allows you to define your own defaults. So for example, you may want to provision all of your Postgres databases in Google Cloud SQL, for example, irrelevant of which cloud provider you're hosting your Kubernetes cluster in. We also have an open API, which allows you to integrate with custom technology you might have. So maybe, for example, you have some kind of internal proprietary data store, which you need to spin up copies of in order to provision a new environment. That's really easy to do with Humanitec's open API. So in-house tech can be used straight out the box. Well, not straight out of the box. You can build integrations which are available for you straight away. So you don't need to worry about the right technology being available already in Humanitec. And finally, auditable. So we talked a little bit about tracking history and so on. One of the big advantages is if everyone is moving their development through an internal developer platform is you have a full history of every deployment. And you also get to compare the configuration across different environments. Humanitec actually goes one step further, and we provide source control-like functionality, like diffing and patching environments, so you can easily roll back or build from subsets of configuration the desired configuration for a particular environment. So we're really introducing the concept of having source control for environments rather than relying on source control in a non-environmental setup, which actually turns out to be a little bit tricky. So, in summary, we've answered 3 points, hopefully. The first one being, what is an internal developer platform? And so we've talked about the fact that it is something that is used by developers and administered by DevOps. And the key thing that it's trying to do is improve the developer experience. If you have a great developer experience, you have happier developers, which also means that you have better software being produced. The other thing is we've asked why you might need one. And the main thing is when DevOps type tasks are bottlenecks. So that's maybe too few people in your development organization understand how to do things, or maybe people are confused and overwhelmed by technology like Kubernetes. And finally, we've talked briefly about how you can use Humanitec to get there fast. We've said that Humanitec is your out-of-the-box internal developer platform. So you can get started very quickly without spending a year, 2 years building your own internal developer platform. And finally, to make sure that it's easy to use, we have said that Humanitec is simple, easy to use, easy to set up, extensible, in that you can bring your own technology and you can integrate it with whatever system you like, and it's auditable. So we track everything, and you can get a whole host of useful information and tooling to help you make sense of what's happened over time in your environments. So, thank you very much for joining, and I hope you have a great day.